fly kind of thing for purposes, but you know, like a dozen machines or less. Okay, that's pretty good. All right, how about, what's the next level? Like 50. Okay, so that's about the same number. 100. I don't know. 500. Wow. Okay, I didn't expect that to go this fast. 1,000. All right, we're getting there. Do I hear 4,000? 2,500. Okay.
Can I get 500?
All right. So hopefully everybody can see there's
more than 5,000. Or
how
our
many?
customers anyway, rates more than 5,000. Some of our.
There you go. Well, that beats me. So not that I'm not about comparison. As an agent, I have nothing to make up for. Wow, that's on tape. Not the kind of video I wanted to be saying that is. Different one on the internet. But hopefully, you know, so we can see there's a pretty wide variety of deployments that we have. This is going to segue very nicely into the next talk where we talk about hopefully a different set of environments and a different set of restrictions placed on using Puppet in such environments. So hopefully I won't mess your name up too much, but Alban? Yes. All right, here it is, embedded Puppet.
Hi everybody. I'm Alban Peignier from the small French company. And we're using Puppet to make this kind of thing, the software, not the hardware. And we are using Puppet to create small boxes with free software for your customer with a radio solution for streaming, to recording, to make audio bridge, something like that. And it's working. We're using Puppet for two things. We're using Puppet to create the image, which is stored in a compact flash. And we're using Puppet to configure the box when the user and we're using Puppet to configure again the box when user want to change the IP address, want to change the streaming quality, and something like that. So when we say embedded, it's not a TomTom device. It's an embedded system. Nowadays you can find Atom with Joker or more. You can't find a memory module smaller than the half gigabyte. And now the small memory card is 2 GB. The last constraint in your environment, in fact, for embedded system is you need to use the read-only file system on compact flash if you want to have a running system during several years. Without that, the compact flash will die after a few months. So, the point. We don't use Puppet like anybody in this room, because we're creating a file. We're creating an ISO file or a disk. And Puppet is running without booting the system, before the booting can boot, in fact. We're creating a bootable images. And we install a complex software set because it's read-only. You can't install a basic image and say, okay, when I boot, I will apt-get install all the software for this box. It's a read-only file system. So Puppet will do all the job, and we store the resulting image on the compact flash, and it's the box, and it works. We use a lot of different solution before choosing this one, making this one. There is a lot of existing base tools or similar tools. There is distribution tools. If you're using a Debian or Red Hat, Fedora, or SUSE, you can use Mash, and you can create a directory with a base distribution. In Debian or Ubuntu, there is their bootstraps, and you have a begin of a bootable system. It's not a bootable system, but good base. There is similar tools to our system, but the most famous one is Peignier. You can build, it's the right term, you can build an entire embedded system with microlibs, with a lot of standard for small embedded system, like but in your case, we're using a lot, in your small box, there is a Raise app. So install a Raise app into a pre-boot system, it's a lot of work. So we make different choose. Our choose is using a distribution. In your case, Debian, that you use what you want. We want to use the distribution into our box, not our own distribution with star, make, and anyhow. We want to use an existing package because there is a lot of chroot package for your jobs to stream, to record, to make that jack, and so on. We package all your own software into Debian package, so it's not a problem for us. And if it's missing, create a package. We want to manage code, as we say, code is everything. We want to create a pre-process to make a box. We don't want to create a box manually and say, okay, ready, next seed for the next customer, I can do it. We want to create, we are 2 developers in the company, so we want to make a rake, just enter, take a coffee, go back, and the box is ready, the card is ready. And we want to manage several projects. For the moment, we have 5 different boxes, and there is no limit. We need to share code. It's not we want, we need. But before, we try a lot of things. Like everybody, we try share scripts, make file, we try rake file, what is the last try. And it's easy. It's easy to have that. Grab the kernel, is good. It's great. But it's very slow script to do that. And if you want to install Apache, if you want to install Rails, if you want to install directories, Icecast, anything, a small software, not a database, just a small software, the script becomes very, very low. And it creates a very heavy build because it's painful to create a script which can detect that Apache is already installed. So you install Apache every time. And you have to spend 10 minutes to build a small 200 megabyte file, which is the final result. So, after a long break file, we create a small gem, which is system builder, which is born from the break file with Untitled. Beautiful code. The objective is only to create a simple bootable system. It won't do anything else. It will install the Debian for the moment. and will create, will follow all the small steps to create a bootable image. It's read-only oriented. If you never run a read-only system, you can take a Debian, for example, and with 2 or 5 modifications nowadays, you can boot without have to write on the root file system. It's very easy, but you have to know what is possible and not possible in a read-only environment. It's free software available. This is a piece of code, but I don't think you see it. No, it's a beautiful piece of code. With tickling line, you can. It's a rake code. In 6 lines, we define you want what is this? A disk image and not an ISO image. You want to use a Debian boot, and you want to use Puppet configurator. With that, you can start a rake list, and you have something like a bootable system. What is system builder? It's really short. It gives you rake text. You don't need to write Ruby to use it. In fact, for the inside side, it's an API to work with chroot image, because to prepare the image, we use chroot. Everybody uses chroot, in fact, in this case. And it provides several logic to manage partition, file system, bootloader, init, ramfs tools. Certainly don't know, but it's the base to boot your Linux. And it's all. But the boot process is very simple. 4 steps. You have to bootstrap the system, in your case the Debian. We have to run several configurators. You can change this list, and you can use Puppet at least. The base configurator will install kernel, will set a default xtab, will set a default result conf, and so on. The next step is managing the container, the images. Take the directory with a nice Debian system, and you create a disk, or you create an ISO file, or you create a Tryphon, or you create something. And the final step is make it bootable with, in your case, system drug. But all this process is managed by a system builder. The small but important aspect is the use of proxy or apt cache, because you need to download the whole CD-ROM to build an image. So you can build on this laptop in bar, because everything is on the hard disk. Puppet, because I'm in this process, you have a magic configurator, which is the Puppet configurator. You say, okay, at this time you have a small base system, and the Puppet configurator will use your Puppet project, something which is really a Puppet project. Small specificities, just like that. But it's a Puppet project, an official Puppet project. And you can use module, you can use template, you can use modules with the URL of the Puppet. And it will run Puppet in a special environment. In real, how it works. We take your image, which is a simple directory with a an etc user system. So only the file, but the system. We install Puppet in this system. The normal Puppet, nothing patch, the real Puppet. After that, no Puppet team, no Puppet master, nothing, just Puppet in the command line. We just have to copy the Puppet file, your Puppet file, or our Puppet file, and we run, and the system builder run in a search root Puppet with the base site.pp file. But you can have a big project with module with editor. In fact, this small ID is based on your bootstrap script for server, for how to bootstrap a Puppet master server. We wrote a few years ago a script, the sit.pp to create a Puppet master server. And when making your box, you say, okay, it's something like that. We have to use Puppet, but without a Puppet master and a network, a complete network environment. There is some specifics. It's not a running system. It's not a system. It's just file. You just need to install package. You have to view, install file, something. But you don't have to moon something because if you moon something, it's for the host, the computer, not for the system. You can start a service. In Debian, it's easy to make impossible to start a service. And you can't load a module or check if a module is loaded because it's not a real system. Outside the 3 points, it's a Puppet code like your Puppet code, but for hardening. I have some code, but with the same black background, so I don't know. We'll try. What we can do with a small image or an ISO file, we can test it. We can test it very easily now with something like Q. You can boot a disk, you can boot an ISO in 3 words in your command line. It's your development environment because you write your Puppet code, you build an image, you update an image in fact. You start Q, you test, you fix your code, you rebuild the image, you start Q, and you can test. And I never really work on device like TomTom device or Arduino or real embedded system, but in a really embedded system you often have to upload your code in a dev device and test it. In your case, it's Intel platform. It's very easy to test, and there is nothing very bizarre. We wanted to share code, and we share code. All your box use the same module to share a lot of things. I don't have to take a small box, but we have to manage the network. We have to manage Happity just for grid, not for the running version, but we have to manage Halsa because we're making sound. We have to manage a lot of shared resources. We have to manage too the really specific settings. Few settings, but we have to manage logs by not really writing logs on the contact line in 10bfs. And all this code is shared in a module And most of features, of user features, are in fact in this module. And when we say, okay, we will provide a way to update the box, in fact, it's a piece of code in Puppet Box module. And in 2 or 3 days, we can update 1 day. In 1 day, we can update all the box and test all the box to see if the new way to configure it is okay with small specificity on every box. And where are your two in the company? It's okay. Maybe I can take the microphone and try to show some comments. Do you see something? No, yes, lot.
The colors are returned.
Let's try.
Is it possible to turn off the lights just on the front? That's much
better. This is a piece of Puppet code. This is a normal piece of Puppet code, but it's configured an embedded system in a chroot environment. You have a file, you have a package, you don't have a service. Useless in your case. And you have two resources to manage the fact we are in a redundancy system and we need to use tempfs for this directory and we need to create a directory for varlog because varlog is created from scratch at every reboot. So this is the build process, the piece of the build process, but we're using Puppet to build a small compact flash with the running system. After that, just a thing. With Puppet and this kind of beautiful script, if you can build an image or a system by running a rake dist, you can build the system by using buildboard to anything like that, push control, and you can make official image on control environment because my co-worker was using Ubuntu and I used Debian and it's quite the same thing, but in our image we have problem with the wrong version of syslinux which not manage the FS, the VFAT like Debian 1. So now we have a build boot. We can build in 10 minutes a complete image from scratch, from scratch. We have a project for a hitbox, and we can create an image, a complete image, 200 megabytes for the moment. We don't need to upload on the ID7 line the file, and it's created on a server in the data center, and it's really faster to make it downloadable by a customer. Next step, you have a box which works, it's fine, you sell it. But you have user, and user want to change settings. User wants to always change settings. It's our job. It's their job. We have to did we try another solution? No. We choose Puppet. We say, okay, I have to change the network settings on the box. Let's try to use Puppet. We're managing user settings and we're managing redundancy specificity for the boot. you remove shell scripts and init scripts for that, and we're using Puppet adult. So this is the moment where the user click on edit and Puppet, you try to change the settings. Configure our box at runtime. It's only Puppet, no Puppet master, no Puppet D. It's only local file, static file. It's not very complicated Puppet configuration. It's a read-only system. You can't update. You can change 5 or 4 or 5, but it's only what the user want to do. In fact, it's a small site.pp installed by the boot. Small classes file, few tables, and the masterpiece is a small pp file. It contains the user settings, in fact. It contains the variable defined by the content to say, okay, I want to use this IP address, I want to use this string quality, and so on. To manage this setting, we're using web interface. We're using Razor for that because our Rails application just are not used just to change the network setting. I know PHP too, but each of your box have several features which are available with web app, this web app. So the settings, the user settings part is only a piece of this application. So it's a big application. This application writes the wanted setting into the file and just invokes script and wrapper to syslog and so on, but just invokes sudo puppet blah 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 site.pp, and your box will be updated or not. But you know, you have error, you have log, you have a lot of things. We're using Puppet and special times too. We're using Puppet at boot. We're using Puppet to use the user configuration, which is the only file which is specific, in fact, in the box. You have a static file and you have a config.pp file. When the user reboots the box, we have to read this file and say, okay, what do you want? Maybe not what he tried the last time, but you want to use the store, the same settings. So Puppet is run before the network on the Debian, and we're creating the file configuration for network. We're creating tempfs workspace with the empty directory, with the empty file, with the right permission, and so on. And everything is done by the same site by the site.pp with the tag, boot tag. And we don't have to reboot the services, we are booting the system. We don't have to check everything, we just need to check the needed resource at the boot. There is a good thing, there is a bad thing on this system. There is a good thing like templating, because you don't have to create a Perl script, a shell script, a readable script for each file you have to manage. You have an up-to-date detection, so it leads to this feature. The user, if he changes the string quality, don't have to wait 1 minute to reboot the complete device. If you change a parameter in fact a process, this process will root and all the box will continue to run normally. And it manages another thing is dependency. It's something quite simple, but if you have 5 processes or 10 processes in the box and you forget to root one of them, for user it's not a big and good experience. Some of problems. You need memory because Puppet use memory, but we are using runtime, so we have memory. We need speed because running a Puppet on a site.pp very tiny, but you have to put all the Puppet code. So on Atom platform, we don't have problem because it's huge. On small, the first image is Helix motherboard with half gigahertz of CPU or something like that. And on this platform, it's difficult to run Puppet without disturbing the running process image. In our process, are running audio. So if you have 1 second of problem, you have 1 second of wrong. So please keep Puppet as small as possible.
Yeah.
Good. System to follow. I can show you the background allowing to. I can show you a piece of log with a complete build. A build of logs, not a complete build. I don't run all the Puppet script because it's too long. But I have a log with a complete box creation. Let's see. So this is a log of system builder. I could build a box, but it's a demo, it works, and I know it, so this is the log. This is the system reader. We say that he has 9 configurators to run. Configurator will do something like create an host file, update the RPT descriptor, something more complicated like install the kernel. Change time zone, blocks, change the Debian policy to avoid service start. Install Puppet. This is the Puppet configurator. It installs Puppet. Puppet is already installed in this case, but if needed, it installs Puppet. And then this is the Puppet configurator. We creating an empty directory in the chroot environment, and we copy. Where is it? Here. We copy all the Puppet file in a temp directory, and we run a small piece of command line, something like that. And Puppet will try to update our system in a small directory. In fact, it's not a running system. You are into build root with chroot. And this is without color, a small piece of Puppet code. Nothing to do, in fact, because the box was already built in this case. After Puppet, we just have to configure the bootloader. In your case, Initrum FS and Sys Linux, S Linux. We updating UTM-FS. We clean the image. After that, it finishes the image is ready. We remove proxy configuration. We remove downloaded package and so on. And we're creating, in this case, the squash-fs, which is a read-only compressed file system, with the directory. The image contains the directory we use to configure the system. We create the squash-fs file, which is the root file system, in fact. We create a disk image, or the image already created. We copy into the right partition in the disk, in the file, which is in the disk file. We copy the squash-fs and the kernel file, and we install. Where is it? We install the MBR sector. And it takes on my laptop 5 minutes from scratch. All these projects are free because all your projects are free. So system builder is the gem and project. Streambox, Speechbox, Linkbox, and so on are free project you can rake. You can run your own rake task to create your box. And you can find it on the website. And it's on the Peignier. The share module is free, everything is free. And this is for embedded Puppet. Question?
Yes. Do you preserve the site PP across readers, or is it getting lost because they were really fast?
The question is site PP persistent? Site PP is into the read-only file system installed by the grid. So only the config.pp, which is included into the site PP, which $network underscore something, is persistent. The user chooses the persistency of this file. You can make a change. You can change the network, and if it does not work because you can't go back to the web interface, you just have to reboot the box, and it will use the last saved config.pp because in the front, in the web front, you can save the config.pp. User don't know it. You can save the configuration, and saving the configuration is saving the config.pp on the compact flash. It's the only persistent system file. Another question? Yes?
One of the points that hit home for me was the Puppet small point, which I felt personally is something that I'm very interested in also. The aspects of the size, you characterize it. There's the memory footprint while running. There's the on-disk footprint of what's required. There's the time also aspect of it, the speed, CPU usage. Do you have a relative weighting of where the importance is and where your pain points are? Where do you feel the pain most on size?
Oh, the question is no. But what? How many CPUs and memories is used by Puppet to run? And did I have? I don't have a numerical value say, but on the running system, the site.pp is a small file, something like on the line there. On an Atom CPU, it takes 5 or 6 seconds to run. There is a bootstrap. There is loading, blah blah. We can make real test and bench and time and so on. But yes.
I think the question was which hurts most? Are you most constrained by memory or most constrained by CPU?
I said memory because on the very first slide there is a motherboard. This motherboard has don't know how to say in English. We can't change the module memory. It's 200 megabytes, something like that, and we need 100 megabytes, and it's difficult. We can run Puppet, but it's not in the stable version of it. But we're working to make Puppet usable on this platform. Yes.
So follow up with me afterwards because I'm very interested in working with them.
Yes.
So what drove you to use to not use a client server? What was the driving point to have you do local everything?
Because the box go to the customer somewhere in the world, and I can't. And the settings are changed by the customer on the box. So data are in the box. User is with the box. At the beginning of the project, we think about a Puppet master on a server and say, okay, we will manage upgrade, we will manage a lot of things with a global network with Puppet master. But in fact, we have read-only file system, and it's, to upgrade the box, we download a new read-only file system. In fact, it's a small, it's a less complicated operation for the customer to say, okay, I want to upgrade. It works, it don't work, but there is no partial upgrade or something like that. On other projects for box, but with RDX for a small NAS or something like that, audio station, we are thinking about Puppet Master, normal Debian, and the real life to use a normal deployment with a local web application with local settings, but the user can't see the difference with the local or the normal settings.
Well, follow up me afterwards. I think you could get the best of both worlds. There's a way where you can just send catalogs to the client. You wouldn't need a client master. So, but it's a little bit architectural different. But I'd like to see some flexibility there. I'd like to see some difference there too.
Those are good. Okay, thanks.
Okay, I think coming up now is maybe about a 15-minute break. So, train yourself and then caffeinate yourself. And then possibly train yourself again. But we'll try and be back